some black holes shouldn't exist, not because they're rare and not because they're hard to find, but because the universe shouldn't be able to create them at all. Over the past few decades, astronomers have discovered black holes so massive that they don't just bend space, they dominate entire galaxies. Some are so large that they could swallow our solar system without even noticing, and yet we still don't fully understand how they formed, because when scientists try to explain these objects using everything we know about physics, something doesn't add up. The numbers don't quite work. The timelines don't make sense. And yet, they're out there, hidden at the centres of distant galaxies, shaping everything around them, quietly growing into something far beyond what we expected. In this video, we're going to scale up, from the black holes we understand to the ones that completely defy explanation. And by the end, we'll reach something so extreme that it might be one of the largest black holes ever discovered. To understand why these black holes are such a problem, we need to start with what should happen. Most black holes begin the same way, with a massive star. For millions of years, that star exists in a delicate balance between two forces, gravity pulling everything inward and nuclear energy pushing outward. As long as those forces are balanced, the star remains stable. But eventually, the fuel runs out. When that happens, the outward pressure disappears, and gravity takes over almost instantly. The core of the star collapses in on itself with incredible force, compressing matter into an extremely small space. In the process, the outer layers of the star are blown into space in a massive explosion known as a supernova. What's left behind is something incredibly dense, a region where gravity becomes so strong that not even light can escape. A black hole. Most of these black holes are relatively small, at least on a cosmic scale. They might have a mass a few times greater than our Sun, or maybe 10 to 20 times larger. Even then, they're already extreme. If one replaced our Sun, the structure of the solar system would completely collapse. But this process has limits. There's only so massive a star can be, which means there's a natural limit to how large a black hole can become if it forms this way. And for a long time, astronomers believed that this was the full story, until they started finding something much bigger. As telescopes improved, astronomers began to look deeper into space, and what they found was surprising. At the centre of almost every galaxy, including our own, there appears to be a supermassive black hole. These are not just slightly larger than the ones formed from stars. They are millions or even billions of times more massive. At the centre of the Milky Way lies Sagittarius, a star, a black hole so large that entire stars orbit around it at incredible speeds. By tracking those stars, scientists were able to confirm that something enormous and invisible was holding them in place. At first, this discovery made sense. The assumption was that these black holes formed early in the universe and gradually grew over billions of years by pulling in gas, dust, and occasionally entire stars. Over time, that steady growth could produce something massive. But then astronomers started looking even further away, which in astronomy means looking further back in time. They found galaxies that existed very early in the universe, only a few 100 million years after the Big Bang, and at their centres were already enormous black holes. Not small ones that were still growing, but fully formed giants. This created a serious problem. Even if a black hole was feeding constantly at the maximum possible rate, there still wouldn't have been enough time for it to grow that large. The math simply doesn't work, which means either black holes can grow much faster than we thought, or they form in a completely different way. And that's where things start to get uncomfortable, because if we don't understand how these objects formed, then something about our understanding of the early universe is incomplete. And then astronomers found something even bigger. Far beyond our galaxy, astronomers discovered black holes that push the limits even further. One of the most extreme examples is TON 618, a black hole so massive that it's estimated to be tens of billions of times the mass of the Sun. What makes this object even more extreme is that it's part of a quasar, meaning it's actively feeding. As matter falls towards the black hole, it forms a rapidly spinning disk of superheated gas that emits enormous amounts of energy. In fact, the light from this process can outshine the entire galaxy around it. From billions of light years away, we can still detect it, not because we can see the black hole itself, but because of the violent environment surrounding it. And TON 618 is not unique. Another system, Holm 15A, also contains a black hole of similar scale. Again, we're talking about tens of billions of solar masses. Objects so large that they challenge everything we thought we understood. At this point, the problem becomes impossible to ignore. Even under the most extreme growth scenarios, there simply hasn't been enough time in the history of the universe for these black holes to reach this size. Merging smaller black holes together helps, but not enough. Direct collapse models offer another possibility, but even those struggle to explain the largest examples, so the question becomes unavoidable. How do you build something this big? And then astronomers found something that might be even more extreme. At the centre of a distant galaxy cluster lies a black hole that may push these limits even further. Phoenix A. Unlike the others, this one isn't just massive, it's uncertain. Some estimates suggest that it could be approaching 100 billion times the mass of the Sun. But at this scale, measuring a black hole becomes incredibly difficult. We can't observe it directly. Instead, we have to study how it influences everything around it, how gas moves, how light bends, and how entire regions of space respond to its gravity. And what we observe doesn't fully make sense. If these estimates are even close, then this black hole didn't simply grow over time. It may have formed through a process we don't yet understand, something that allowed it to reach an almost unimaginable size in a relatively short period. And that's what makes it so important. Because this isn't just about one black hole. It's about the limits of our understanding. Black holes don't just sit in space. They shape galaxies, influence star formation, and play a role in how the universe evolves. Which means, if we don't fully understand how they form, then we don't fully understand the universe itself. And maybe these objects aren't just anomalies. Maybe they're clues. Clues that something about our understanding is incomplete. Because the universe was never supposed to create objects this large. And yet, it did.